All right. Hi, everyone. My name is Michael Webster. I'm a principal engineer here at CircleCI. Thank you for joining this webinar today. I'm going to be talking about how AI is breaking the SDLC and some techniques we're finding effective on how to fix it here at CircleCI. Quick overview of what we're going to cover. We'll do a whirlwind tour of how we got to the current state of AI in software development today, what the current state actually looks like, the problems that we see this creating, and then some things that we're finding effective to solve these problems. And then at the end, we'll do a wrap up for Q&A. One logistics note: if you do have any questions, please use the QA feature in the Zoom webinar, and we'll answer all of the questions at the end. All right. So let's start with explaining kind of how we got to the current state of AI, just as a brief little history lesson. So in 2021, we started to see models come out that were capable of auto-completing code with a pretty high degree of reliability. This was GitHub's Copilot, the initial release of that, the first version of Codex from OpenAI. Then we go into the sort of ChatGPT, GPT-4 era, where we're able to do more than just basic autocomplete. This is where you start to see IDEs that are coming online, that are focusing on putting AI directly into the developer space, putting chat experiences like you would see on ChatGPT in the web directly inside of your IDE. Um, and then then around 2024, we start to see an increase in what started to be called agentic workflows. So models started to be able to use tools reliably. You could have them execute bash commands. There were prompting strategies that worked to discover, based on context, the appropriate action to take for a given task. You start to see models with reasoning capabilities that could break down ambiguous tasks into step-by-step to-do lists, and you started to see models with enough context windows, where they could actually run for a very long time. So instead of just taking what was a GitHub PR comment and trying to fill in a function definition off of a comment, we're starting to see models that are able to think through tasks, try to solve them, and run in loops for a significant period of time. Um, this agentic sort of workflow, that's where we started to see more interest in agents being assigned tasks, right? And that leads us to today in 2025, where we're starting to see this idea of headless agents. Um, things like ChatGPT, or sorry, Codex CLI, and the Claude Code CLI, they start to enter the scene. Folks immediately start saying, well, if it's a command I can run, not a GUI IDE, can I script it? And now we're at the point where folks are saying, well, let's take one of these CLIs, put it inside of a Docker container, or a VM, and run some commands with it. And with that, we're starting to see the introduction of more autonomous agents. Um, how much activity is happening from these autonomous agents is a bit of an open question, right? There's always, within AI, there's a bit of a disparity between the data and the practice. So what I did was I went through the GitHub data. So there's a great project called the GitHub Archive project, that has a daily snapshot of all public activity that happens in GitHub. So every open source repository, anything that's publicly available in GitHub, this project is able to collect it. They store it in Google BigQuery, and you could run some data and analysis on it. I thought it was important to do this because we're kind of making this claim that agents are breaking the SDLC. So it's worth going into some of the data to understand what happens. So this chart is showing the total GitHub activity per week, specifically for known AI coding agents. There's a lot of these coding agents. I picked 5 or 6 of the more popular ones, including GitHub Copilot, Claude Code, Devin. A lot of these agents that were initially released to do work autonomously. So these are the sorts of things where at username, can you fill this in? Or you assign them a Jira ticket and they complete a task and open a pull request. So this is everything that these agents are doing in GitHub. It's a non-trivial amount of data, right? And you can see that the rise has happened very quickly. 2025, March of 2025 is near where some of these things started to actually be released. And then you can see an initial slow adoption, and now the adoption is going quite quickly. Now this is total activity, but we can drill down further using this data set, and we can look at the actual event types that are occurring. And this is where the story on these agents starts to get quite interesting. So initially, when you look through this data set, what these agents were doing was mostly PR reviews, right? They're leaving comments on issues for issue triage, to detect if an issue appeared to be a duplicate, or they're doing sort of basic code review status. Like the example of pretty much all of these headless agents running inside of a CI pipeline was doing issue triage and code review, right? It was a really common use case. But you can see around May, they actually start pushing code, right? And this is a little bit different now, right? We're not just sort of having the AI, you know, make sure that issues that are commonly opened are formatted properly, or issuing comments. They're actually writing code in these repositories, and that trend has only gone up. That sort of knife edge you see at the end of the graph is data recency. But these agents are now writing about as much code, as they are in some cases issuing comments, and pull requests, depending on the week. Um, so this graph got me particularly interested here because maybe that's all just people experimenting, right? When a new feature comes out, when a new product comes out, people want to try it on their repositories. So I went and I looked at CircleCI's data. What do we see across all of our customers, and ran a similar analysis looking at these agents. Um, and this is a trend that we see internally. So I went all the way back to 2024 in this case. That's when Devin first launched onto the scene. But you can see very similarly in 2025, late spring is when the usage of these agents dropped up, or started to spike. Now, the interesting thing about this one is these are actually pipelines that were triggered. So this isn't just activity. This isn't someone pushed code. This is the CI pipeline actually ran in response to a change from one of these coding assistants, right? So someone has actually done something to set it up. So when I look at this, I see, okay, yes, there seems to be a lot of activity happening in the public spaces. Could all just be people experimenting. But when I look at CircleCI, where we are actually trying to validate changes that are coming through from real world projects, many of them that are not accessible on the public GitHub timeline, um, the trend matches up. So the absolute numbers are a little bit lower, which you would kind of expect, because again, these are things that actually have explicit CI pipelines set up. So this is not just someone working on a hobby project that has no CI whatsoever. Okay, so I want to be clear as well. This is a low end estimate here, right? We're looking at 5 agents, the most popular ones. There's a few that are excluded because detecting them reliably inside of the GitHub data sets is small. This is not going to include developers who are just using tools like Cursor, Claude Code, or Codex, in order to write code, but then pushing it under their own names. This is purely work that we can absolutely tie definitively, to one of these coding agent products, and only a subset of that. So this is a subset of those agents. So this is a low end estimate. The reality is it's probably much 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 higher. Um, but when we aggregate all of this together, we kind of see there's about, when you look at it across the GitHub data set, there's about 200 plus assistants that are AI related. Um, there's a few million GitHub events that are attributed just for coding assistants, so a subset of that 200 plus. And then within CircleCI, that adds up to about 250,000 pipelines. This all happened within about 6 months since a lot of these agents went sort of GA, where you could actually assign them a task, and have them attempt to complete it and open a pull request in GitHub. So that's a very fast growth curve. And to me, that's pretty convincing enough that this trend is quite real. It is likely to keep growing over time as these tools get better and adoption increases. Um, Now, one question you might have is, why is this actually a problem, right? So great, we've got more code being produced. We have systems to deliver code. What's the issue here? And to talk about that, we're gonna have to think a little bit around constraints and bottlenecks. We'll do a little queuing theory, but no, not a ton of math. Um, so the reality is that most software delivery processes probably couldn't actually go much faster, even if they wanted to, right? So this is a simulation that I ran, that made some assumptions about how frequently is code being introduced? How long on average does it take for that code to be reviewed? And then if you assume that the code comes in faster than at a given rate, then what does that do to the amount of time that you've been waiting on something to happen, right? So to be clear, the parameters of the simulation, we're assuming like everything takes about 60 minutes from code review, rework, addressing feedback, merging the PR, deploying it, getting it into a customer's hands. We assume that all can happen within a 60-minute period of time. That's a pretty elite delivery pattern, right? Some industry benchmarks say that the P75 on merge time, like for a PR to get merged itself, is 55 minutes. Right. So like the real world data says most of that it's going to take you almost an hour just to get the PR merged. We're assuming like you are kind of an elite software delivery organization, and from the time a PR is opened to the time that feature is in a customer's hands would only take 60 minutes. Um, and then we say like, okay, well, what if AI makes the speed of that software faster? If we go under various scenarios, and what you start to see is it doesn't take much of a speed increase to be able to really swamp your delivery process, right? At AI just being 20% faster, if you keep that 60 minutes time, you start to see separations over time. So for the purpose of the simulation, we kind of did like a 24-hour period, right? Like what would a day in the life look like if you worked at this rate? Um, and even at a 20% increase, you're starting to see basically your every day you're ending with a backlog of work that has to be waited that's waiting to go into production the next day. It basically becomes an unstable system relatively quickly, and it just gets more unstable faster as you speed up delivery from AI. So if folks are wanting to use AI to make them 5 times as fast, 10 times as fast, 100 times as fast, like the reality is that if you do nothing, and even if you're already elite in terms of getting that software into the customer's hands, you're going to eat all of those speed gains by waiting for stuff to be deployed, right? And that's a pretty big problem because this assumes this like happy world where there's never any conflicts, you never have to roll things back. But the reality is you would be waiting, days and days and days if you do nothing for these changes to actually be released. Now, this is a simulation, right? It makes some assumptions. Maybe those assumptions apply to your organization, maybe they don't. But the theory that we're seeing also aligns with more subjective anecdotal feedback that we're hearing in the market. The 2025 Dora report that focused on AI-assisted software delivery, they showed that there was actually an increase in instability from AI, and it wasn't showing effects on product performance or even like burnout for individual engineers. So you would think that like reducing the amount of code that an engineer had to write, having more of that delegated to the AI might improve things. But Dora is saying actually it makes the delivery processes more unstable, and it isn't necessarily helping with the engineers. Um, there's other data sets that show that when teams that are using AI assisted coding, their review times actually go up, right? Part of that is due to an increase in size, right? There are several open source projects that have mandated AI disclosure policies for PRs because suddenly they were getting 1,000-line PRs out of nowhere, clearly AI assisted, not always that great. And those PRs take a very long time to run. So we're in a situation where what we would expect to happen seems to be lining up with what's happening in the real world, and I think that creates a problem for all of us because even if we can make the code faster, if we can't get the results, then what's the point? All right, so what can we do to fix this? How can we fix this? I'm going to tell you some things that we found to be effective within CircleCI. We'll talk a little bit about what's going on under the hood with these agents to give you some intuition about how to think about these problems. But a lot of these are open questions right now. I think we're going to have to figure this out as an industry. But I'll be sharing some things that we found that work quite well. Okay, so what you can do in any given situation, this is the standard tech lead answer. It depends, right? And in the case of AI coding assistants, what it depends on, literally, is the context, right? It depends on context. So, and let me tell you what I mean by that. So let's do a quick look under the hood of what's happening with an LLM. So this is a very simplified version of the math that's going on under the hood. In a given LLM, with a transformer architecture, which is the dominant paradigm today, the probability of any token output occurring is the probability of that token given context of everything that came before it inside of inside of a request to the LLM. So when people talk about LLM being the next token predictor, that's what they're doing. Based on the text or the tokens that have come before it, the probability of any given next token um, is conditioned on that context. Now, so that means that if you want the right token, the token that you would expect, you need to be really careful about that context that you provide. That's a single LLM call, and then agents add some dynamicism to this process, right? So, what exactly? Let's talk a little bit about what exactly is an agent, right? So what an agent is it consists of a model, some tools that you provide, right? So in this case, in this scenario, we have the ability to run bash commands. We have the ability to pull test data, run specific commands to capture coverage. You give it some task, right? In this case, we're saying like fix my tests. And then you run that agent in a loop until some sort of check occurs that says that the task is complete, right? That check could be a deterministic check. That check could be the model deciding that it's reached the end of an input and that the next most likely thing to do is to stop responding. It could be cost related, could be time related, but the point is you run this agent in a loop as it goes through, right? And all of these tools, all of these tasks, the results of the checks that you're doing are all consuming context from the agent as it runs. So how much context are we talking about here? This estimate comes from Jeff Huntley, who has worked a lot on various coding agents. At a presentation he gave in September of this year, in practice with modern coding agents, you have about 175 tokens that are actually available to you to use to complete your task. What that translates to in human language is about 300 pages of text, right? So a 300-page novel would take up about 150,000 tokens. By contrast, the Linux kernel is 50 million tokens, right? So even though the overall model context windows are increasing, the amount that can effectively be used is much smaller than the overall context. So what that means is it really pushes the pressure of, if you want to get the most out of AI, you really need to effectively manage that context and make sure you're providing useful context, not spending a bunch of time on things that aren't actually helping the agent achieve its tasks. We'll talk a little bit more about that when we go into into some of the approaches that we're finding effective internally. But I did want to start with this theory before we go into the details. Okay, so we've talked about context. We've talked about the overall speed increases that are occurring. So how do we put this together into something that we can do effectively to address these problems of more code coming in, but our delivery process is still being a bottleneck? Spoiler alert: it's probably stuff you've been wanting to do for a really long time. Um, so I'm going to start with sort of this concept of blocking and tackling. If you're not familiar, this is an expression from American football referring to sort of fundamentals being important, right? So there's all kinds of new approaches, techniques, concepts that come up in football, just like in technology. But at the end of the day, you got to get these basic skills right, right? And that applies just as much to AI delivery as it does to sports. So to give an example of this, like let's go back to our simulation. And in this case, what if we made the delivery faster, right? So in the prior simulation, we ran a case where we kept the delivery the same, but just started producing more code. Um, but we can also run these simulations and say, well, what if the delivery got faster? And what you can see in this case is the changes. You still see increases in queue time, right? This is sort of a fundamental fact, right? If you're pushing more work into the system than the system can handle, you will always have a backlog. But the curves don't go up quite as sharply, right? Under these scenarios, right, we assume we only make delivery 10% faster. So we only shave, 6 minutes off of the delivery time. We're able to get some pretty decent results. And even if you hold the code rate constant, making your delivery 10% faster gets you significantly below the status quo. Now that's pretty impressive, right? So even if you assume the value of AI is zero, that it provides you no benefit to writing code. Just making your delivery system faster is going to reduce the amount of time that you're spending waiting for work to go out into production, right? So what that translates to is like that's more attempts for you to deliver value to your customers in a given window of time, with relatively modest increases in your delivery velocity. I want to be clear, a lot of this stuff isn't fancy, right? These are some quotes from internally from CircleCI, from some interviews that large companies have done. Like, we're not talking about multi-agent orchestration tools or trying to figure out the latest prompting strategies. A lot of this stuff is basic, right? Uh, Replacing a slow script with a faster script. Internally on one project, we saw it take a key deployment step down from 8 minutes to a second, right? Um, Investing in tools to automate changes across all of your code bases so that you can keep things consistent. Making sure the right people are included in a pull request review instead of just blindly saying, "Here's a code owner's file." Like this is all fairly basic stuff. AI can help, right? Most of these cases are fantastic to be assisted with AI, but you really do need to invest in these fundamental factors, right? If you can cut these things down, then you're immediately going to see benefits to your productivity, to your delivery throughput, to your velocity, or whatever metric you use, DX Core 4, Dora. Those things will immediately accrue, even if you're not actually necessarily using the latest and greatest agent tools. So my advice here is make things better for tomorrow you, right? Every team has some backlog of technical debt. There are slow tests, flaky tests. Everyone has those code bases that they know every time. No one wants to touch it because every time they do, it breaks, and then they become the person who is the expert on that code base. Um, so my recommendation today is like start leveraging AI to pay down a lot of that debt, right? Use the AI tools to convert the scripts to speed them up, right? Use them to automate the extraction of things that maybe you were programmatically generating in some really complex way, and putting them into a script that's easy for you and your developers to find. Uh, we can help with that. Chunk is our agent that we're building out right now. It works with flaky. Right now, it's focused on improving flaky tests to fix those to stabilize your delivery pipelines. We're also launching an adaptive testing feature to speed up your build times by selectively running tests. These are all things that are um, these are all things that are solvable problems. Everyone knows they have problems, um, but if you're going to go all in on AI, you need to invest in solving them. Unfortunately, though, that's still really not fast enough, right? Um, you go back to those simulations we see with AI getting faster, making code writing faster, you still become unstable in delivery. You still in the day with a giant backlog of stuff that's waiting to be processed, that you have to come in the next day, and then you just fall further and further behind. The issue here is AI creates a system problem, right? Um, Improving delivery speeds is really helpful, but it doesn't address the system level problems. At a high enough throughput, you still get swamped. No amount of tweaking, no amount of script extraction or optimization is going to work. Those optimizations all take time. You have to actually like dig in and understand what needs to change, right? So in a lot of cases, you might find you can't fix a problem. Um, so and what this leads to is like every system that we've ever built, every technology system, every language, um, every editor, right? All of these things have useful lifespans, right? And our take is that a lot of the existing approaches are getting close to those existing lives to those useful lifespans. Um, Things like code review, things like approaches to testing, the way that software gets deployed into production, and the amount of gates and bottlenecks and manual actions that have to occur. Um, those things have never really been ideal, but they're now becoming significant blockers to the hundreds of thousands to millions of dollars that companies are investing in AI to hope that they improve their delivery speed. So when you have a systems problem like this, it's really hard to change the system from within, right? You need to pop up a level, and sort of look at the system as a whole and find out how you can tune it. And ultimately, you end up building a new system, right? Um, I want to be clear here. We've been here before. We've run into cases where we've hit problems where some new technology comes out. It has a lot of promise. It turns out that taking advantage and being able to realize a lot of that promise is really hard. And then we go through cycles of learning how to do it, learning how to manage the pain of those new technologies, and eventually we wind up with some kind of abstraction that is quite easy to use. This applies to the data sets in this presentation, right? The 15 years ago, if you had wanted to analyze activity at the rate that we had for the GitHub data set, you would have been signing up to rack a bunch of machines inside of a data center, um, spending millions of dollars to do that, figuring out how to build some data ingestion pipeline, spending a bunch of time reading message boards and mailing lists and reading stack traces to understand how you can actually get these systems to analyze the data that you have. And now, 15 years later, um, you can go to Google, put in a credit card number, and actually within the free tier, you can go analyze petabytes of data very quickly, right? This is an ongoing trend in technology. I mean, I think AI is the same thing. I think it's important to remember that this cycle of bottlenecks being revealed, figuring out how to tune around the bottlenecks, and then how to eventually eliminate the bottlenecks in the first place. This is a large part of what we do as technologists. Okay, so what does that look like today? Right, it's all well and good to say let's reinvent the SDLC, but what are some specific approaches that we're seeing effective, that we think are promising, that we think could eventually become approaches to address this? Right. So going back to our agent model here, context is the biggest lever that you have today to manipulate. Right, and everything you have eats context. So the tools, the prompts, processing results, all of those things consume context. Um, and the number of levers you have to manage context are actually relatively small within the agent. Um, what here, what I'm actually recommending is you start at the bottom up, right? If you start with your ability to verify a given result, to make sure that it's good, you can then feed that back up into the task. And then once you figure out how to assign a task to an agent, you can pull that up into a tool, right? So if you like a basic recipe for what this looks like, right? If you're using feedback from your CI system, from your build tools, from your test runners, you use that to get the model to produce the results you want, right? So you keep prompting it. You have something in place that can tell you that it's good. You absolutely need that. And then once you've done that, once you've gotten the model to produce something, you have a way to verify that the results the model gave you are good for your use cases. Then what you can do is you can take all of that sort of tweaking and prompting that you did, and you can use that to extract those into rules to get the model to perform a task, right? So now instead of having to waste all your time running through the checks over and over and over again, or letting the model just sort of guess at what to do and then having to run through these expensive checks, you can guide it on what it should do in the first place so that the checks are more likely to pass the first time through, right? And then once you've done that, you can turn those rules into abstract tools that you can give the model generally. These are the like a lot of times these are like skills and things like that are currently on the market today. Now, if this sounds familiar, it's the same way that we build software libraries, right? You hack around to get something that kind of works for your use case. You find out that it actually applies in a couple of different places, so you pull that into a helper, and then you find out that that the multiple use cases actually apply to lots of different projects and lots of different environments and contexts, and so you pull it up into a library and you figure out how to parameterize it. So this is I want to be clear, this is a recipe, not a formula. This is the thing that you have to play around and tweak, but it is something that we're finding good results with internally, right? This notion of prompt the model until you get it to produce results, ask it to summarize the process that it did to produce those results, and then abstracting those into things that are reusable for everyone else in the organization. Another thing we're finding super useful is using feedback itself as context. Um, and what I mean by that, this goes back to that sort of check down there at the bottom, right? If you can provide the agent with an exact problem, it's going to be much more likely for it to be able to solve it and match on that problem. Um, but in order to do that, that feedback needs to be able to deliver fast, right? It doesn't really do you a ton of good if it takes a really long time to run the tests, right? PRs are currently a source of feedback, but they're actually quite slow, right? It takes a long time. You have to find a human to go review the code, and they leave you comments, and then you have to go back and respond to those comments. So the testing and PRs are probably some of the first bottlenecks, but they're really important to get right, because they are currently the best way that we have to produce, to gather feedback. So taking a lot of the events that are happening inside your PRs, understanding how your code base and your tests relate to each other. Those are ways that you can significantly cut down the amount of guessing the model has to do by taking the feedback you're already giving on the outputs and using it to produce better outputs in the first place. So I'll give you an example of our adaptive testing feature and how that's helped with that. So this is some numbers from the total wall clock time of one of our internal projects that had a pretty gnarly test suite. It took about 30 minutes to run with a high degree of parallelism. We were able to cut that down in absolute terms to 1.5 minutes. That's a significant speed up. That's the sort of thing where if you provide a tool like that to the agent, instead of waiting several minutes to run a test suite, it can run a very specific subset based on the files that it's changed. And you're able to just get more reps and more throughput from the agent. Feedback also has to be accessible. This is the thing I think we lose sight of sometimes with LLMs. Tracking down the commands to run eats context, right? This is the lesson we learned with Chunk, our AI agent. We initially let Chunk sort of decide, figure out how to install dependencies, and set up development environments. And in some cases, it could do that, but what ended up happening is we spent a lot of our time and our execution budget on trying to read through package.json files or CI config files, to infer what was happening, right? Just finding the commands was consuming a ton of context for us. So making these easy to find, again, it's a pretty basic thing, but it's super important, right? LLMs will read docs, unlike humans. It's one of the few things that they have access to that they can read. They have no choice but to read something. So give them something to read that's useful, right? Today, like what that looks like is it's already a practice I think some folks follow with CI. Put that stuff in a file, right? Whether it's make or just or me's task, whatever your tool manager of choice. Like when there's specific actions that need to occur, don't make the model guess. Make it context efficient. The Anthropic has come out with their skills. Most coding agents at this point have some kind of plugins or sub-agents capability or slash commands. These are all ways for you to be able to say, um, here is how to achieve a specific task. Here are the prompts that you need to go through in order to achieve it. And so you take a lot of the guesswork out. You're consuming less context because the model only has to use enough context to find what to do, and then it can just go and do it. Feedback also has to be continuous. This applies to continuous integration, but just in general, right? Like right now, nothing is purely AI or purely human in most organizations, right? We're in sort of this transitional period. So it's really important to make investments in systems that get better, right? We've seen model providers swap leads of who's the best coding agent all the time. One day it's OpenAI, then it's some new Gemini model, then it's OpenAI again, then it's Anthropic. Like none of these models appear to have like a dominant effect where they're just winning everything. So it's worth it for your organization to be able to just capture this information so that whatever trend comes along, whatever new improvement is available, you're able to take advantage of it, right? In order to do that, you need to make things portable. And again, this is a case where models can help, right? What this looks like in practice when we're using a model to do this is like as you are figuring out how to do something the right way, going back to that sort of basic recipe I showed before, use the model to extract the instructions that you then give to the model to complete the tasks. This is actually an example of this internally, right? So I've talked about Chunk, our flaky test, our agent. One of the things it does is fix flaky tests. One of the things you can do with Chunk is you can give it specific instructions for your repository on how to deal with tests, right? There's a lot of testing tools out there, in particular for end-to-end testing. So this is a screenshot of a thread that one of our developers did with a coding agent, basically asking it to maintain the custom instructions that we provide for Chunk to follow, right? So we asked it to ensure that that we followed certain guidelines from Playwright best practices, right? So this wasn't the human reading Playwright best practices, copy pasting them into the section. This was saying, hey, please make sure that we adhere to playwright best practices. The agent, in this case, was able to turn those into rules, and then the developer could then say, okay, great. I now have a new set of rules. Let me apply it to the same task that I was just trying to perform and see if I get a change that does adhere to the playwright rules, right? So this sort of feedback loop where you're using the model to improve context that you provide to the model, we're finding pretty good results with this internally. Feedback also has to be early, right? And this is probably the part that's maybe the most uncomfortable in the SDLC. Um, a lot of we talk a lot about shifting left, but in practice, a lot of the feedback that blocks a change going to production happens pretty late in the process. Um, there's a lot of things you can do to get feedback earlier. Small batch sizes are a really common approach. There you absolutely should be working in small batch sizes. But again, when you're working in a system with the typical SDLC where code review, security scanning, the all of the final checks that have to happen in order to release production happen after the code is written. If you dump 10x the code into that system, that system is very unlikely to be able to cope with that level of change. So what this ultimately comes down to is trying to get feedback on work as it happens, and then doing that in a way that's verifiable, and that will satisfy compliance and security regulations. This is a super open question today of what this looks like. Today we use draft PRs pretty aggressively with some sort of AI coding assistant. So what that does is it gives us a way to get some amount of knowledge about our full CI pipeline as the agent is building. But we find that's quite slow because sometimes the CI pipelines take a while to run because they're built to assume a very large change set, not the agent working incrementally, right? So while this is an open question, I think there are some things you can do today. Um, what that looks like in practice is probably pushing things through your CI pipeline more than you historically would, which created its own set of challenges in terms of latency and cost that we're looking to manage. But we think that if we can get the feedback down fast enough to occur as it's happening, that's really the key to unlocking a lot of these throughput benefits from AI. Um, so just as a quick wrap up, um, of this presentation, right? AI agent adoption is real and appears to be growing, right? We see this in public data, we see this in private data. Um, but at the same time, we start to see that there is some early indicators that there's some negative effects, right? It's not uniformly beneficial. There's likely to be a lot of variance here. There's a previous webinar with some folks from DX that they find there's a lot of variation amongst companies and how they perform. But it's definitely not helping everyone equally in terms of their ability to deliver software. Fixing your delivery process, which again is probably a thing that lots of teams have on their backlog of the build being slow, is quite beneficial. It's actually the quickest thing you can do to help reduce the impact of AI pushing more code through your delivery pipelines. Right? It doesn't take a ton of improvement to the delivery process to be able to start making fairly significant increases to your development speed. Unfortunately, there's a limit to patching the system, right? You absolutely, like right now we have to fix the systems as we find them. But at some point we're gonna have to move above that and change the system itself. And we think for that the main challenge there is managing context, right? How do you effectively get the instructions on how to achieve the work you want to achieve in a way that is quickly verifiable um, for the models is really crucial. Um, so with that, thank you for the presentation. I will cut over to the see if there's any questions in the Q&A channel. Okay, so we got one question. Do specialized QAs fit into this process anymore? Um, I definitely think I would say like I think the knowledge for sure does. I think figuring out how to come up with a good QA process and turn it into something for an agent to use makes a ton of sense, right? If we're going to trust the model to write code, I do think that QA skills become really important and being able to come up with systems that are able to quickly verify them. Those probably look a little bit different than traditional QA skills, but I would say yes, some level of specialized Q&A or sorry of QA does fit into this case. Um, what level of access does Chunk need to be able to fix flaky tests? Yeah, great question. So Chunk is built on top of CircleCI's existing test intelligence features. So when you run build pipelines in CircleCI um, and store test results with us, we keep track of the results of those tests, and then we detect if they're flaky. You know, if a test will pass and fail on the same git commit SHA, that's usually an indicator that it's a flaky test. Um, what Chunk needs is, it has access to that information, right, via the CircleCI API. And then we have a GitHub app that has write access to the repository. Um, so yeah, so using our GitHub app, which you would install and authorize, Chunk can then write changes to your repository. Yeah, good question. So I believe during the beta period, there's no additional cost. So Chunk it runs as compute, so there's compute credits that are charged for it. We also it's a bring your own key model. So instead of CircleCI making requests to the model, you provide your own key. Um, so there are inference costs associated with the model, but that are part of your organization. We do that mostly for security and privacy reasons. But yeah, it's free to try right now in the beta. And then based on how we fix tests, eventually that's where the pricing would come in. All right, it doesn't look like there's a ton of additional questions in there. Um, so yeah, well, thank you all for joining today. Hopefully there was some interesting information in here. Um, and yeah, if you're interested in this problem in Chunk, reach out to us here at CircleCI. Like we're definitely interested in talking with folks on how to solve these problems. Great, thank you all.